All right, so welcome. First off, a couple questions. I like audience participation. Who's ever heard of Python? Awesome, you guys are in the right spot then. Who's developed Python scripts? Sweet. So you guys know some of the pains with that, and we'll hopefully talk about some of those throughout and how we can make it easier for our SOCs to develop Python or just really develop the SOC program in general, right? So with that, this clicker's working, sweet. Who am I? Well, you guys didn't really come here to hear me talk about myself, so we're going to move on and start talking about Python. Before we can do that, we need to set some foundations, right? We need to set the stage, per se. First, good old NIST coming to our rescue to find out what a computer security incident is. I'm not going to go through all this, but I want to point out the key point here. It's a violation or an imminent threat of violation to our computer security, right? Really, it's around your policies. So good policies can really define your incident response teams. Next one I want to get out of the way, what's the incident response process? Hopefully everyone probably has seen something like this. This is also in this definition here. It could be 4 steps, it could be 7 steps, it could be 18 steps if you really wanted to. Hopefully you're not putting your security teams through that, but it's a possibility, right? But we're going to show how Python kind of really helps with this. It's going to help with some of our preparation work. Actually, it might take a little bit of extra preparation, but it can be there. It'll help with our detection and our analysis. Helps with maybe our containment, reaching out to multiple different tools for us, right? Maybe take some of those manual actions we do on a day-to-day basis and making it easier for our SOCs to understand. And then post-incident activity, the fun part, right? Reporting the incident. Writing down all that documentation of exactly what happened. How can Python maybe help us with that? Cool. So that's the incident response process. We're going to move on now. We're going to go into some of our problems that we're facing and what are we trying to solve, right? So as many of you probably know, we have a lot of isolated security systems in the industry. It's getting better, right? We had SIMs supposed to help centralize our logs. Then we have EDRs that are supposed to help protect that endpoint. And then we now have XDRs that are supposed to be doing what SIMs were originally intended to do, right? And let's face it, each vendor still wants you looking at their screens, right? That's where they want you at. So what do? Well, you bend the knee and you go look at their screen for one alert, go look at another screen for a different alert, because they got more context around it. XDR can only pull what the API provides, right? API is just application programming interface, just a way to strip out the pretty HTML and what we see. So we got that as a problem. Data is all sorts of different formats as well, right? It's not always centralized. So we have JSON, CSV, XML, binary. I work a project where we had binary log data that I had to go through and start looking at the vendor's documentation on each byte and hex so I can write a converter to actually understand what that log meant. I thought I was done with that back in 2007, but apparently not. We have still documentation, right? Documentation is great for our new people. Our senior guys that have been there for a while, how many times do you think they go read the documentation? Probably just to update it for the new guy, right? Coming in. So how can we use maybe Python and some of the stuff we're going to talk about to help us with that? And then limited visualizations, right? We're getting better. EDR's got a lot of fancy graphics out there in the business halls, right? Try and make it easier for us to see it because we're human. We like to be able to visually look at something. Lines of codes, at least my eyes go across every time, especially with logs and you're dealing with millions and millions, you're just scrolling. And eventually you get, oh, the file is too big, I can't open the file anymore, right? Really fun. And then lack of context, right? I get an alert. Who's the owner of that computer? Where are they to my organization? Is it a C-level exec that I actually need to probably put the white glove service on for? Or is it customer service rep? Is it someone in HR that just opened up a resume, right? And that provides different context about what's going on that alert. And it can be very beneficial to understand. So we have some of these problems, right? Before we develop a solution, we need to talk about some considerations that need to be around the solution. Knowledge, right? I can go write a C++ application to do something, and then someone else coming in and they're going like, I don't know, that was compiled code somewhere, I can't read that. Knowledge about the organization, it also becomes tough at times to pass down. A lot of things become tribal. So how do we document that? How do we make sure that something that we're doing now is going to benefit our SOC, our IR leads down the road? Adaptability, right? We get a new tool in probably once every 6 months. At least when I was on the corporate side, that's what it seemed like. And if I was really lucky, some big breach might have happened on another organization, and I got a lot of funding. So all of a sudden, I might have like 20 tools coming in the door that I've been begging for years. Right, so we've got to be able to change. Got to be able to adapt to these surroundings. Company mergers happen, right? McAfee, FireEye, the Trellix brand now, right? That happens. So now how does that change my tooling around that? Some new spaces are coming out. How do I integrate that into my processes, right? And then consistency. We have to be consistent in our incident response process. Have to be something that we can reproduce over and over again. We got to be able to bring up our next level of analysts, right? Our level 1s up to level 2. How do we maybe do some of that? And then, of course, ease of use, right? Because no one wants to spend more time trying to use the product than it would take to just manually analyze the data themselves, right? So if I'm only going to go look at something that's 10 log lines, well, it might be easier to go look at 10 logs than go look at 200 lines of code to analyze those logs. So with that, we can use Python. And I like to introduce Python to the rescue on this one because really it's flexible. It's open source. Open source means you go look at the code, do your code review so you feel better about the product, right? Flexibility on it. Python is object-oriented. Everyone heard object-oriented programming? Couple? Yeah. So really, a string is a string. But with Python, I can use a plus sign, and I can concatenate two strings, put them together. But if it's integers, it adds them for me. So I can have loose definitions of an object. Variable can be a string 1 minute, and it can be an integer the next. I don't have to change a lot of stuff. Makes code a little bit harder to read at times, especially if you get someone like me that just says A equals X, or 1, 2, 3, B equals ABC, right? It happens. But there's also a lot of great community support out there, a lot of libraries to integrate with all these different products you guys probably have in your organizations that your SOC has to interact with. If there's not, that application probably has a great API, right? That probably can get data out or do actions for you on your behalf. And if all that else fails, most of these products are HTML anymore, right? So you can literally interact with it through HTML code and submitting boxes through Python. So great, it's got capabilities there. It's OS independent, runs on Linux, Mac, Windows. And no, for many folks in here, it does not work on Google Chrome. Sorry guys, I looked that up. You have to run an emulator. So, but it's got a lot of flexibility. And that means I can write code that works on various different analysis platforms, okay? So that's great. And it's human readable, or at least a little bit more human readable than most, right? If I say for X in Y, I understand I'm looping through something. If I say print, well, I'm going to print something out to the screen. If I have an if statement, it says if as part of that. So it's a little bit easier to understand for new folks that maybe haven't done that before, right? So we got a kind of foundation. We're going to talk about Python. But where do we get started? Like if you're coming in and you haven't had a lot of Python experience, or maybe you're just trying to set up something for your security operation teams to be able to use and collaborate with, how do you get going? There's so much different Python capabilities out there, so many different things to look at. Let's talk about some foundations. Right? So Jupyter. Anybody heard of Jupyter besides Planet? So hopefully everyone's starting to catch the joke on front of the slide. Awesome. So Jupyter comes into a couple different flavors, really. You got Jupyter Notebooks, Jupyter Lab, or Jupyter Hub. And really think about Jupyter Hub is your server. Jupyter Lab is kind of your interface. And then Jupyter Notebook is the actual page you're going to be interacting with. And I said interacting. This is a web page. It can run on your local box or it can run on a centralized server. It has a bunch of built-in features, including IPy widgets, which allows you to create buttons, input boxes, allows you to do text boxes, HTML code if you really wanted to. I'll show some examples of that later on. It can be hosted on a centralized server for your teams can interact together on this, right? So a centralized place. You're not having each developer or each one of your incident responders writing code on their local box. You can have a centralized server for that, which means we can also do some restrictions on who can access what, right? It allows for sharing and documenting, right? The big one, documenting the code. Everyone's familiar with the hashtag in Python scripts where that's how you had documenting, you had to do a whole bunch of hashtags, and everyone may do them slightly different, may put a nice little hashtag line going across to separate their comments, might not, might be 48 characters, might be 200 characters. I know that doesn't follow PEP, but it happens. So there's a lot of flexibility here that we can use Markdown as part of that. So Markdown is just another quick formatting language that allows me to do stuff like you see here in the slide where I can have a bold heading, I can have text, I can have bullets, I can call out what this is supposed to be doing, and a little bit easier to read for my SOC. Next library I want to introduce is Pandas. Anybody played with Pandas? Couple hands, right? So we're all now data scientists. Congratulations. Add that to the resume, right? So Pandas is normally used for a lot of data science, but it's also great for incident response because we can take and load data from all sorts of different places. HTML pages, CSV, XML. We can write some custom parsers to throw data into it. We can massage data before we load it into this Pandas object. And Pandas object, for those that have never heard of it, think of it like Excel, but programmable. It gives you a data grid view of it. As such, it also gives you the ability to filter it. So you can apply different filters on there. You can do SQL. So T-SQL syntax works on it. If you really want, if you're SQL backend, know that, comfortable with it, great, you can do it. You can use more of a pandaism where you do .column, .locate, whatever you want to do on that. But it gives us the ability to filter our data, maybe even before we do some processing of it. And best of all, allows us to export data, right? To a normalized CSV, Excel file, wherever we want to do, push it to another database. Allows us to get the data export. Because we all know how much vendors sometimes love us, the ability to export data out of their products, right? That 1,000-row limit, maybe 5,000 if you're lucky on that product. So we can use maybe APIs to get around some of that. And this can help us do that. Cool. So, whoops, click too much or press too hard. Now it's not cooperating. Thank you. So let's put everything together, right? So let's start showing how we can do this, how we can invest this into our SOC and make our lives hopefully a little easier, right? Or at least our SOC guys' life a little easier. So first off, setting up the environment, right? I highly recommend the Littlest Jupyter Hub, TLJH. It's a great little base startup, especially if you're just getting started. That allows you to set up a server centralized so your incident responders can access a single platform to start this process up. You can do it from pip. If you want to go through and install via command line, not a problem, right? When you're building this environment up for your SOCs, think about how you can leverage that server. It's potentially going to be able to tie into all of your security products. It's going to potentially tie into maybe sensitive data areas where logs might be stored, right? So think about restrictions around that. How can I secure it? Limit it to only your security teams. Maybe limit the subnets. But it also gives you a single point that you can allow into those other networks that's maybe a little more controlled. Put some additional security controls around that packet captures so that you know exactly what data was being sent back and forth, right? And then think about what libraries you want your teams to be able to access. You might have NumPy, so for some numerical math. Pandas, right? Hopefully everyone sees put pandas in there. But you can do these cool shared libraries. And then Jupyter gives you the ability to have independent libraries. So each one of your users can then install their own libraries and not affect everyone else. Set up some shared folders. Now I'll show a screen example of this in just a second, but a lot of great capability in sharing folders and then restricting those. So then your senior guys that are probably going to be writing these Jupyter notebooks, right, are going to create these playbooks, create the scripts, put it into this folder. Everyone else can run it, but they can't modify it. So now you got some type of controls around it. And then maybe set up something shared, because let's face it, we have a lot of great talent usually on our teams. They might come in as a level 1, might want to play with something, so let them create something and be able to share it out with the group, right? So we got this, we stood up the server. There are a couple things that I always recommend kind of changing. One, Jupyter, the littlest Jupyter hub, has some default configurations that are not optimal for usually an incident response team. One, change out the default app to Jupyter Lab. That way they log in directly to their notebook, and you're going to see their notebook down here at the bottom. Two, change the timeouts. Jupyter Lab is a shared environment. Each user has a session associated with that is independent of every other user on there. So there's some timeouts associated with it. By default, it's like 10 minutes. I don't know about you guys, but I don't type anything within 10 minutes if I'm writing a code, because usually I'm typing it, oh, I misspelled something, backspace that thing up, right? Oh, what was that file path? Go out, find the file path. Oh, how do I integrate with this API, right? And so by the time I'm done writing the code, my session is timed out. I'm like, oh, great, gotta go back to that. So change some of those. These are just some recommended. Slides are not gonna be available, but the recording, if you guys ever wanna go back to it, is available for the next 30 or 60 days, something like that, in the event app. Cool. So you got this up, you got it configured, boom. You open up a web browser, you point it at that server or to the local host if you're running on your local box, because guess what? If you want to play with it, spin it up on your local computer. Don't waste the time going through IT to request a server, right? You can just spin it up local. Here, you got all sorts of great options. You can create a new file, go Python 3. Yes, you can still do Python 2. We're not going to talk about that animal right now. But see, they have some shared folders already here available to every new user that comes in. And it's user controlled. Uses the Linux backend to control users as well as its own. So now I can have users log into this as their own profile, have some user accountability. And then I can restrict those users to what folders they can access. Once I open up a new Python 3, I get a new little window, new little tab open up here, and that automatically saves data for me. I don't have to keep hitting save all the time. It's automatically going to start saving that. So I'm not worried about my system crashing and I lose all my work I've been working on for the last 2 hours because I forgot to hit save. Now that has done that to me before, but you get the idea. So we got this great little interface, web-based. I can run Python. What else can I do? So inside Jupyter Notebooks, the big power of this comes down to the cells. Those that experience Jupyter Notebooks kind of know what I'm talking about here, right? Each cell can be a markdown, so I can make it as a markdown, put bold headings on there. I can do all sorts of great stuff there. It can be code, in our case Python, and I can run each one of those cells individually. So my import cell, I run it one time, and then those libraries are imported for the rest of my progress. This includes variables being defined. So if I bring up a script, I can prompt for a username one time, and I can use it throughout my code, right? So this makes it pretty nice and flexible for when you're going through and debugging. Those guys that built Python pages, you know, you're 300 lines in, you run it, 20 variables later that you had to input, error, forgot to close off something, or, oh, no object is there, right? So this allows you to write code blocks, simplifying your code into different segments. So you run that segment, saves that output. You can use it in your next one. All right, so how do we feed pandas? I talked about a little bit HTML, CSVs, but how do we actually do it? First up, you import the library. If you'll see this quite common is import pandas as PD. This is just shorthand, pretty standard shorthand for pandas, just like NumPy is usually NP, so if you ever see that. It allows us to save typing. And then all I gotta do is call out to my data source with various different functions built into pandas. Our example here does read CSV. Pulls out whatever CSV sample I want. I tell it to parse the dates. I tell it to ignore columns in a CSV because there's column headers associated with that. So if I don't need every bit of that data, I can actually exclude it out here. I don't have to process all of it. And then, because I'm in Jupyter, I just call honeypot.df. And it will display it to me as a data frame. That's what that's called. There's all sorts of cool add-ons for pandas. There's Mito sheets and all sorts of fun stuff, but you got a great start here. You can see it as a table. You can visually look at the data to make sure it's what you're looking for, make sure it parsed it out correctly. Then you can start doing some transformations on that data, and we'll show it here in a second. So great, Tracy, CSV, I can open up that in Excel, right? Why am I going through all this work trying to learn Python and Jupyter and pandas? Well, what about this? So I have a sample of Zeek logs publicly out there. I see a bunch of extra headers at the top, some extra text. I have a non-CSV, it's probably tab delimited in my case, but it could be something else. But I know it's Zeek, right? So how do I load this data? I can't load this into Excel. I probably could with some finessing maybe, but usually Zeek logs are also pretty big. So do I really want to? So let's look at how we potentially can do this. I bring it up, I import my pandas, and then I'm introducing a new library here called Grok. Everyone heard of Grok? All right, so now we know who our Elastic Logstash or customers are, right? So Grok is popular with that platform, and basically it's a simplified pattern matching algorithm. And they got a bunch of built-in stuff here, or you can define your own. The cool thing about Grok, like over regular expressions, a little easier to learn, and you can define types for it. So I know what type of data I'm getting out of that. It's not just going to be a string where I have to convert it later, right? So I know in Zeek, I got a Zeek header, so I create the pattern for that. Then I know I'm dealing with HTTP logs, and that's the data I want to match on. So there's my next one, right? And this is all sample, so play with it, work in your environment. Some logs are all put together, some logs aren't. Then I create the Grok parsers for each, which is my next line there. And then I can run that cell. And guess what? I don't have to rerun that. My parsers are defined. I can then go down to my next one. I'm manipulating the data, figure out how do I actually get this data in. So in this case, I decided to use a while loop, or a for loop, excuse me. So I use the context handlers with open. So it opens up the file for reading, pull that data in, and then I'm parsing it out based off from those Grok statements. I say, hey, if it matches, parse it out. And then, thanks to Grok, it puts what's called a dictionary. So it has a key value pair as part of its return. So now I can apply additional algorithms, additional functions, parsers to other parts of that message I just parsed out. And that's what we see on the next part, where we take HTTP Grok, match it up against the message field of my previous one. Cool, and then I throw that into a data frame, and I got usable data. I got destination IPs already parsed out, because otherwise I would have had to run it like a regular expression grep statement maybe for those, pull that out, unique it, not necessarily fun on the command line, but I also got something repeatable here, right? Cool, websites. Pull directly from any HTML page that has a table in it, right? Pull it down. Usually there's a lot of different tables associated with websites, so I might do something where if you see a square bracket, that's accessing an element of an array. An array is just basically a list of items here. And then you can pull that out. So this is just some random GitHub page that I saw that has some data. So I pulled it down. Cool. So it has all sorts of great flexibility. You can pull into databases, right? Create a database connection. In this case, I'm using SQLite. You can use Oracle, MySQL, or not T-SQL, but oh, mine just went blank on the other. You can pull it from a Redis database, whatever you want to do, right? Here, anybody recognize .mans extension? No? Got a couple over here? All right. So that's a redline package, or if you're Trellix FireEye customers, the triage collection. You bring it up into redline, it parses it, and basically throws it into a SQLite database in the back end. So now you know mans is actually a .SQLite table, and you can actually have a lot of fun knowing that data. So then here, I'm just pulling in, this is just a sample. I write a literal SQL statement as part of that connection, and it pulls it into a data frame for me. And now I can continue to manipulate the data. So as you see, there's a lot of different ways to feed pandas in this case, right? So let's go on to some actual fun stuff, right? We actually want to see this in action. See it in action? We got set up an attack here. First up, the scenario. Probably all have seen this before, right? Suspicious parent-child process relation, in this case, Microsoft Word, spawn PowerShell. Great, right? Another resume application coming in for our HR department. But let's take a look at how we can do this, how we can enable our SOC. So the first thing we're going to want to do, remember our incident response process, is we want to collect the triage, right? So here I have a basic triage script. In this case, I'm using GR, the Google Rapid Response, as my collection engine, right? And anybody ever use GR? No? Couple? It's all right. Like, it goes out and we'll collect data, but if you ever have to collect data, it's like individual. Collect shim cache, collect file listing. It's a little bit manual process. Through the API, though, you can specify a whole bunch. So then I can have a predefined filter of what I'm collecting. And my individual SOC, tier 1, is not going to have to remember, oh, did I collect that box? Did I check that box? Did I check that one? So I can continue going on knowing that I got all the data I needed for this collection. So I run it. PyWidgets displays a nice little input box for me. I can actually type out the data that I need to. I run each cell, go down, I collect the data, interacts with GR, and then I can save it out. I can save it as just basically a pickled object, which means just a dump of the data into a variable that's stored on disk, and I can actually access it later through another Jupyter Labs notebook. So really cool, right? So I've collected data. I'm done. We're moving on now, right? And we'll pull up a playbook. This goes into our documentation that we talked about. How do we make it living? How do we make it dynamic? And now my playbook is associated with the code that's actually going to help my incident responders. So now they have to look at it. Now they're actually going to say, oh, this no longer makes sense. Let me go ahead and update this. Or this is exactly what this is supposed to be doing here. So I brought up a playbook, in this case, suspicious interactive parent-child process. I say interactive because usually Word is an interactive program. So it's displayed on a screen. People are typing in. And I tell you what it's going to do. Now, this is just a sample, right, created for the course. Hopefully your documentation is a little bit better than mine in this case, but gives you the ability to do that, and that's just in Markdown. From there, I can have each step documented. I want to have different sections. I want to run my first section, which is going to prompt for some imports. Here you see I got a custom script from my IR scripts. Maybe it's my Intel API in this case. Right? I can then collapse it, so I'm not looking at that. I already know it's been ran. I can then import the data. This is going to use that pandas data object that we saw earlier. Imports it from the man's file or SQLite in the backend. And now I can run all sorts of code here associated with that. I can apply my IOCs as part of this. In this particular case, it's got some pretty print trees to make it visually interesting for the individual user. It's got my IOCs where I'm going to look for something called PowerShell, because that was my IOC for this playbook. Now I run it, and you can see I start getting data out, and it's displayed to me pretty nicely. And one thing cool, you can right-click on this output, put it into a new window. So now you can have that output just sitting over here on the right-hand side, easier to potentially look at. Cool. So I got my WinWord. I know the process IDs. Part of my documentation would be tracked by process ID. Once I have that, I need to go into my next step, right? And this is all one playbook. I see this logically going through. So my tier ones that are just coming in can follow this, right? And get maybe some additional knowledge as well because they see where is this data coming from. I go show network connections. Great. How am I going to run this? So I just click in there, shift enter, or right click. It has to supply the process ID. This is process ID I want to investigate from above. I need to know if there's any network connections associated with it. And lo and behold, I got some network connections here. Gives me IP address because that's part of my data, right? So I'm not having to go through and filter. I'm not having to change out my windows. If I was in Redline, that could take a little bit to load, right? So I got the data available. I can rerun that, put in a different process ID associated with it. And now you see I got a bunch more information here. I'm at this point thinking we.exe is definitely probably bad. Spools SV, why are you connecting out to this IP, right? So then I'm going to grab those process IDs, go to my next step of my documentation. Once again, making documentation useful. And then I can run it. How did that process come into be? Where are my parent-child relations? So then I can start seeing, oh, we comes out of ctemp was launched by a command here. ctemp pse.x talking out to my Cronin DC. Well, it's probably bad news, but hopefully you kind of see that it's starting to help, and when we can pivot into various different processes, see how they came to be, what is the process tree, what are the command lines, because that's all captured as part of my other data, but kind of nice, right? It's all right there. I'm not having to jump into different tooling. My SOC hopefully is learning a little bit. So then we could go, got our investigation done, we save it out using the .2 CSV. And in this case, I'm just pulling out specific information relevant to those processes. And what's nice is this is still part of that playbook. I can define this as an organization or my seniors saying, this is the information you need when you're investigating this process, right? And now I don't have to worry about my SOC tier 1 potentially missing it, or maybe my MSS, right? Because we know we all have to document everything to the nth degree for an MSS at times. So then I can open it up directly in the web browser, and if this is on my local box, it's that file stored locally. If it's on the server, I can then download it to my box and be able to see all the great evil in our case. We're going to have a conversation with this company later on, but you got a lot of great data here. So that's our incident response, right? Not going to go through containment, but you can continue going down that tree and have this as one playbook. Or maybe your containment is a different playbook based off from what you found previously, right? And it can interact with your network access controls, your firewalls, your email gateways. But then we got to report it. Our favorite thing, this is everything that we push down to the SOC level 1 because our senior guys hate reporting. At least I do. So you have maybe a generic reporter. Everything is standardized. Python, you can standardize your stuff. And that's one of the things like we do quite a bit at Mandiant is make sure we standardize so we can easily report on. So here, once again, just do my basic imports. I'm going to load the data previously on there, right? And then I got a format that I want. In this case, I'm going to call this like a system summary to present to the execs or to my manager. Or if you're the manager, hopefully you're getting something nice and pretty back to you. So I can define that. I can ask for inputs on here. I can also pull those out of system information. Who's logged in? What system did they analyze based off the evidence, right? But I can also prompt for this. So it makes it a little more interactive. And then I can save that off. Once I save it, I give it an output name. I can have it static. I can do all sorts of great stuff at this point with the data because I own the code, right? I can, pandas, Python in general is just really flexible. So then I open up. As you see here, we got a great output. Has all the information. I don't have to type anything else. So that saved my SOC time, right? And it's consistent. I have the required information for each one of those for my other documentation or any type of legal standards I might have to follow, right? Sweet. So that's a theoretical example, right, that we walked through. Let's talk about some real world examples that I've actually had to do some of the stuff in, right? There's not a day that I don't touch some type of Python code working for Mandiant. Like there's always something that someone's wrote a little utility for it to help us out, right? These are some additional ones that I want to share with you guys. New product for the IR team, right? Happens. We get some cool new product, or maybe the business bought a product, and you can utilize it for your security operations. In our case, we're going to talk about code repository monitoring software that reviews code repositories, looks for secrets, passwords, usernames, AWS keys, Oracle database connections, things like that, right? Well, that's great. If you got a large source code, well, that's not so great for you because most likely your devs have been putting credentials of some type in there for years. And so you're probably going to be looking at a lot of events. In this particular case, we had roughly 10,000 hits on here. That's a lot. And we had to also think about how do we maintain this going forward. So what do? We started analyzing a little bit of the data and realized that the product is great at detecting credentials, but not great at pairing them. So we had no idea what that username actually went to. Was it an actual Oracle, or was it some other connection inside the same config file? And that's what we were seeing. So Jupyter notebooks plus pandas came to the rescue for us on this one. We built this little custom dashboard you see here using just HTML. And we highlighted different colors. So, hey, this was a new credential detected. Where was the server matching? And you can line it up. And that helped us do the analysis of that. And then we took it the next step where once we had those mirrored up, we were able to integrate with Strunk where the logs were and go searching for that data as part of this output. So once again, a little bit easier on that aspect. And then of course, the dreaded data not centrally logged, right? If you're talking large investigations, this is not uncommon, especially like Linux servers. You may have a couple thousands of those in the environment. So this particular case, I say there's only 100 plus Apache servers. There were a lot of Apache logs, like over 5 terabytes of data we had to go through on it. So there's no central logging, no way we could get credentials into every single one of those servers. So what ended up happening, we set up a jump host. We executed Python on that jump host that had access to every single one of those. We used pandas to load up the data and start doing some pre-filtering for us, and we were able to get that down to a manageable size of 10 gig before we actually started doing our analysis on the data. We were able to do the filtering based on from IOCs of the investigation and also some known stuff, like we know this box talked to this one as a repeated process, right? So another great win. The last one here, repetitive processes. We've all been there, right? Previous life, I helped with the legal hold request process. I'd say process is a very, very loose definition at this point. So legal said, hey, go put this user on legal hold. Okay, where's their data? No one knows. Did you put your mailbox on hold? Sure, we did, right? So we started experimenting. In this case, we used Python and PowerShell because PowerShell's, let's face it, better interacting with Exchange than Python. So we started developing some scripts to do this part for us. And then we brought in Maltego. Anybody play with Maltego? You got a couple of you, right? So this is back before their instant response transforms in there, but Maltego is really cool. You have a graph, an object, a node, basically. You can right-click on it and do some transforms. So do something to that data where it takes it in and goes, either looks up something, usually used for OSINT, so open source intelligence, right? But I was like, my legal team's not very technical. They're not going to understand a bunch of logs telling them where this data was. They want something graphical. So I was able to use this, create a beautiful little graph, had the node of the user, and then showed all their directories that they had, what computers did they own, what mailboxes do we put on hold, the dates associated with that, where the data was actually stored, and the case numbers associated with that. So then I provide that to legal, and legal's like, sweet, I can actually understand this, right? So it made their lives a little bit easier, and also mine, because all I had to do was right-click on a couple things versus trying to go search 30 different places to put this data on hold, right? And of course, we didn't have any actual budget for any discovery solution, so put it together. But the screenshot shown here is one from our Intel has a Maltego transform, where you can actually use Maltego, talk to the Mandiant Advantage API, bring back some cool stuff based off MD5s. So let's kind of wrap it up. Right? I've been talking for a while. You guys are probably going to sleep, getting the hunger pains at this point, ready for lunch. With Python, Jupyter Labs, and Pandas, you can really do a lot of stuff. I want to encourage everyone to get out and have your teams experiment. If you're the managers, encourage that, right? Because you could be amazed at what your teams can potentially do for you. Couple takebacks, right? Automate one manual tool action that you're doing right now. Is that going collecting data from a particular endpoint, putting a user on hold, right? See, as my mic goes out here, see what happens. See if it works for you. Spin it up on a local box. You don't have to spin it up on a big server. Try your documentation in it. Take one of your processes that's pretty repeatable. Maybe you made it for your MSS that might be out there, maybe your tier ones. So it's real documented, pretty rigid on data collection. Put that into a Jupyter notebook. Have your team interact with it. So that way they can see, oh, fresh documentation. And then play with them a little bit. Change some of it. See what they say. See if they actually notice it, right? Don't put it as an actual test to them. I don't think they'll take that part. But enjoy it. Have some fun with this. And then automation in the collection, right? All these systems, we're getting better at talking to each other, but they're still separate. They may not have as great of information in one tool as they do the other. So try collecting the data that you need. The secrets that one that I gave an example for, the API only gave me out X amount of data. It wasn't everything. The report gave me even less data out of that. So I had to do a combination of the report, the API, and then also even did some web scraping on it. So I could actually get the actual source code out of there. So have some fun with it. And if you're just getting started, I got a couple different resources here. My kids have got me on YouTube. Yeah, it happens. Most of my YouTube is Minecraft. Oh, something tech, finally got it. There's great books. Other fun stuff, if you like some of the comics you've seen throughout, xkcd.com. I've been watching them for years, love their stuff. But with that, I want to say thank you to everyone. We got a couple minutes here for questions, if anybody would like. No? We got a question right here.
So you showed how Jupyter can use Markdown to document the code, and obviously it can run code as well. Can you use it to make reporting so that it takes the outputs of the code and then with the Markdown you can make reports?
Yeah, that's a great question. Can you do reporting off from it? Absolutely. Jupyter Notebooks has ability with some additional add-ons, mind you, to make that as a read-only sample. So it pulls in data and then you can have it as a formalized. You can export that information as well. So if you're using DataViz or some of the other visualization libraries, you can actually have that as part of your report that you can just export out. So great question. Other questions? No? All right, you guys have been great. Appreciate you guys attending. Hopefully you enjoyed the rest of the NYS conference. Oh, we got one more? No? All right, you can talk to me later. I can be back over in the corner if you guys have any questions, and then I'm wandering around throughout the conference as well. So thank you guys.